Well, now let's take a look to Pyro. As I mentioned before, we're going to evaluate which attributes are relevant in Pyro for us to achieve what we're looking for, the fine dust. So let's start with geometry node. Let's dive inside. Let's use an object merge. I'm going to try to not spend too much time explaining the basic stuff, just quickly build up this. Let's go here because we need to get the grains. We're going to use it as a source. By the way, I haven't shown how this look, so let's quickly create a playblast for this. It has some, as you can see, some custom values and random values on the attraction weight, and it's kind of moving. You know, this is super low res. This is definitely not the resolution we're going to work, but it helps us to quickly get results, tweak values. What we're going to try to do now is this kind of look. This is still low res, but it's showing very good pyroclastic look that resembles a bit the reference. But still, this is very low res. The purpose of this quick test is to also find out which attributes are going to help us to get the result we need. So let's continue here. I'm gonna put some kind of guide visualization for this. I'm gonna use CD. Use the length of the velocity. As we know, velocity is a vector, but when you use the length of the vector, you get the amplitude of the vector. So basically we get a float value. In this case, since we're using CD, which is kind of a vector too, we need to create probably like a set. We're gonna use the 3 values of the color RGB. So let's use length here. Let's use 0, and then let's use 1 minus length of velocity. Close brackets here. We will probably, let me see what I'm doing wrong. Yeah, this is pretty bad. my expression here. Deleting that add and adding this here. This should be fine. So let's see. Yeah, this is showing where the actual velocity. So the higher velocity is represented by the red color, and the no velocity is represented by the blue. Now let's blast everything that is. Let's kind of create a threshold for this length of velocity using the color. So we can do something like CDX, which represents the red, is less than 0.5. And then we select points, because sometimes I don't know why this is not working automatically. So we're now separating the particles or the grain that I'm going to use as a source. As you can see here, if I select we have a lot of attributes, and this is going to make Houdini to behave a little bit slow. So better to clean all this, especially because we don't need it. So I'm going to keep only velocity and p-scale. I'm also going to create some kind of control of these two attributes. So in a wrangle node, I'm going to multiply pscale by an attribute. It's a channel, and it's going to be mult pscale. I'm going to do the same with the velocity. Velocity, oh, I need to create here, again, doing my expression wrong, equals. Instead of multiply pscale here, we do multiply velocity. We promote this. And let's start with some values. I already checked these values and it works fine, so that's because I don't want to experiment too much. I need to do this quick so we can jump to the actual setup. Just let me do this with using the values that I already checked, and those were working fine. So now let's do VDB from particles here. VDB from particles. We're going to change some values here too. We need to keep this very small so it reads the actual small volumes. We change the size to 0.025. We can keep the density of this. We're going to create, this one, the radius, we need to change it to something like 0.138. And we're going to create one point attributes that is going to be the velocity. It's going to be, select the vector type and name it vel. This is the default name of any volume when refers to velocity. So vel is the name of velocity for the volume. Okay, let's do one more thing. Another wrangle, but this time it's going to be a volume one. So we can multiply also the velocity, the density here. So density multiply equals density. Right? And check this. For now, let's keep this in one, value of 1. This might not be necessary, to be honest, because you can also multiply the density value in the .NET. So I just like to keep that extra control. Let's create actually a .NET here, but instead let's use the Pyro. Sorry about this. The Pyro. There's some presets here that we can quickly. It's better to use it. Kind of giving us something, some kind of template that we can quickly, change and get what we need. I'm going to delete everything. So as I connect this here, it's a good idea that this voxel size, we use the same on the voxel size of the .NET for our simulation. So paste relative references, we will have the same value, and let's change some parameters here. So first, on the sourcing, we have density already. Since we don't have temperature, we will use density as the source for temperature, and we're going to change the operation to add. It's additive, what we want. Velocity, since I created already in this wrangle node, no, actually no. It should be fine then. It should be V here. Actually, yes, actually I did it here. Yeah, I'm sorry about. So it's actually now called vel. It's not the v, which refers to the point, the velocity. It's actually vel. The source is vel, and and then it goes. The target field is also vel. Let's keep add here too. Let's change. So I found out that the most important values are already on the below e preset are already there. So we can the disturbance, we're going to make a very high scale, very high value here. The block size, we're going to make it very small, and the turbulence, we can leave it like this. Buoyancy, maybe we can do half of this. Also, one important source that we need is not here. We need to add one, is the divergence. So we're going to use the density also as the source for divergence. Divergence is going to expand the volume, the simulation, the dust. It's going to expand it. And when you create pyroclastic look, I think it's very important to have this kind of growing, like the mass is kind of expanding. So it's an important value. So what is relevant on this simulation is we need temperature, we need density, we need velocity, and then we need divergence. The temperature always is kind of like boost, or it works along with the velocity. So when a fluid is hotter, it's gonna react also faster. So that's very important to consider and to know. Every time we want like faster reaction, we can play with the temperature and have increase that. And that will generate like faster buoyancy, faster motion with the velocity, kind of sensitive. We will also go inside and bring the gas vortex confinement. This will help to create like rolling look, rolling behavior in the dust. We also see that in real life. It kind of like the dust is pyroclastic, but it is growing, it's expanding, and it's rolling on itself. It gives a very nice look. And damping, just to control the craziness, like crazy, acceleration with the damping, we can just slow that down while it's evolving. So it's a good thing to use, and I'm going to use the temperature for that. Let's change the background here to dark. Remove this guy. Prefer to have this as a reference. Actually, let's keep it like this, and let's see how this looks. So this is what we're getting now. I'm going to jump inside the gas vortex confinement. Add higher value here. So again, this is a quick setup just to see what is relevant. I think this is starting to work fine. We have this kind of look that we're looking for on the test here. You can see we're kind of getting this look. So this is, but for now, what we need, and we can deduct that the most important attributes are divergence. This is the expansion of the fluid, the confinement to get the rolling, the gas damp to slow down when it's evolving, that kind of like goes against the acceleration, and then temperature. I'm using add because the additive value will increment the behavior and for me that is important. The rest, we can start checking all this, putting this on the test using the actual setup. So let's jump to the setup and work on the real deal.